Hey guys, in this video we're going to be starting KC7. Our first learning objective for 7A.1 is I can calculate missing sides of lengths by identifying the legs and hypotenuse of a right triangle and applying the Pythagorean theorem. So kind of first couple vocab words is, well, what is a right triangle? A right triangle is, let me see if I can write my pen here, is going to be a triangle where one angle is a right angle. And hopefully we remember that a right angle is 90 degrees. So let's write that in. A triangle where one angle is a right angle. So right angle is indicated when we have this little perpendicular symbol. This means 90 degrees, right? This angle right here is 90 degrees, therefore it is a right angle. If you want to, keep that in mind, this is 90 degrees when you think of a right triangle. So the hypotenuse, the important thing is that the hypotenuse is across from that right angle. So if you have, obviously we have three sides of a triangle, so it's the side of the triangle across from the right angle. So once you find the right angle, what you're going to do is you're going to draw a line to the side that's across from it, right? That means that this line segment, AB, is the hypotenuse. All right? That gives us two legs then that are left over, right? The opposite sides that are not the hypotenuse, so the two sides that are not across from that 90-degree angle, are called the legs. So the two sides that touch the right angle. And by touch, I mean that they have that vertex, right? So this segment touches at this angle. This segment touches at this angle. Therefore, this is a leg as well as this side. All right? Once we have all of that together, we have a right angle. We could use what's called the Pythagorean theorem. Pythagorean theorem says if you take whatever leg length, right, we're going to call that A, and we add that, we square A, we add the other leg and square it, that's going to equal our hypotenuse squared. Okay? So you square each side, right, each leg, and then you're going to set that equal to the square of the hypotenuse. So let us go ahead and try that. I do have my calculator here, so if you forget how to square or, you need some help, please go ahead and grab your calculator. And I'm going to leave the Pythagorean theorem up there. So looking at this, it says the directions say find the length of the missing hypotenuse by using the Pythagorean theorem. So the first thing I would like to do is label what is my hypotenuse and what is not. And what are just my legs. So this is my 90-degree angle, so I go across from that. This is my hypotenuse. Notice the hypotenuse is always represented by the C. So this is our hypotenuse, right? Which means that we have two side lengths, two legs. That is 6 and 8. All right, so when we write our Pythagorean theorem, we have A squared and B squared. Does not matter which one you say A and B is, as long as they're both of the legs. So 6 squared plus 8 squared equals our hypotenuse squared. So yes, the hypotenuse is on the other side. It's always by itself. And we don't know what that is. So we're going to go ahead and simplify this. 6 squared plus 8 squared equals c squared. We're trying to solve for c. If you need help, remember that in your calculator, you have that little square button that's right next to the 4, which is 36. Remember, we're not multiplying by 2. We are squaring it. So you're multiplying it by itself. So 6 squared is 36 plus 8 squared, which is 64. And this is still going to equal my c squared. Okay? Then I'm going to combine my 64 and my 36. So 64 plus 36 is 100. Still equal to c squared. And now I want to solve for c. So the way I solve for c is that I want to get rid of that square there. And then to undo a square, you have to take the square root of both sides. So therefore, this is going to give me square root of 100 is 10 equals c. So that is going to be my length of my hypotenuse. This would be 10. All right, so let's try it again. Looking at example number 2. First thing is to identify what your hypotenuse is, right? So this is my 90-degree angle. I have to go across from it. That makes this my hypotenuse. So this is my c value, right? Which means that my 8 and my 15 are going to be my a and b, right? This could be a and this could be b, right? Doesn't matter which one we say as long as that those two are my legs, right? So now let's go ahead and square that. So it's always a squared plus b squared equals c squared. So a squared would be 8 squared. B squared would be 15 squared. And this is going to equal now c squared, which is what I'm trying to solve for. But since I have an x here, instead of using c, I'm going to use x squared. Right? Simplify this out. So x squared, 8 squared is 64. 15 squared is 225. Still equal to x squared here. Uh, 64 plus 225. Probably going to go ahead and stop combining my colors here. So 64 plus 225. Adding these two together, I get 289. Equals x squared. I want to take the square root because I'm solving for x, so therefore I'm going to take the square root of both sides. So therefore 17 equals x. That is my hypotenuse here. Alright, example number 3. I have my 90-degree angle, which means across from it is my hypotenuse, right? This is my C, which gives my two legs, A and B here. So again, I'm using that formula, the Pythagorean theorem that's up here. So A squared, which is 4 squared, plus 8 squared, is going to equal C squared, right? We don't have a variable there. You could use C, you could use X, whatever you'd like. 4 squared is 16. 8 squared is 64, which is equal to C squared. We combine 16 and 64, add these two together because they are on the same side, which is 80, equaling C squared. We take the square root, right? Because that's how we're going to undo. It's the inverse of squaring something. And this is roughly about 8.9, which is equal to C. All right. Go ahead and flip it over to the next page. And we have a couple more examples. So now we're looking for the missing leg. So still same formula, right? I'm going to go ahead and write that at the top for ourselves. Right? A squared plus B squared equals C squared. Looking at our first example here, I'm going to go ahead and label. This is my 90-degree angle, so across from it, this is my hypotenuse. And my two legs, leg and leg, which are my A and B. So when I set this up, I'm going to have A squared plus B squared equals C squared. That's my formula. And I'm going to go ahead and substitute what I know. Well, A squared, I don't have A squared, so I'm going to bring that down. That's one leg I'm trying to solve for. B squared was 12, so therefore this is going to be 12 squared equals C squared. Now they did give us a C value, right? C is 13, and now I square it. So this is what it means by we're solving for a missing leg and not the hypotenuse. But overall, the steps are the same, right? A squared, bring that down, we do not know what that is. 12 squared is 144, and 13 squared is 169. All right, we want to get A by itself, so the way that we isolate that A first is to do the opposite and subtract 144 over to the other side. Therefore, we are going to have A squared, 144 minus 144 is 0, 169 minus 144 is 25. And then we want to do the opposite, so we're squaring something. That means we have to take the square root. Square root of A squared is A, square root of 25 is 5. So that means our missing leg is 5. All right, same thing for example number 5. Across from the 90-degree angle, this is our hypotenuse, right? This is our C. We can have an A and our B over here. And then we're going to substitute into that equation, right? A squared plus B squared equals C squared. Substitute what we know. We have this leg, we don't know what that is, so therefore that's my X squared. My B squared is over here, which is 8. My C squared is over here, that's my hypotenuse, which is 20. All right, now our goal is to solve for that missing side, which is X, and then we simplify. So X squared plus 8 squared is 64. 20 squared is 400. We want to isolate that X squared, so we're going to go ahead and subtract 64 over to the other side. We're going to have X squared is equal to 336. We want to get X by itself, so therefore we have to do the inverse. So if this is being squared, we take the square root. And the square root of X squared is X. Square root of 336 is 18.3. Okay. Last example here. Label everything, right? Find that 90-degree angle, go across from it. This is my hypotenuse, which is my C value. And then we have our A and our B here. So A is 11 and B we do not know. So substituting into our Pythagorean theorem, A squared plus B squared equals C squared. A squared would be 11 squared. B squared, we don't know what that is, so that's just B squared. And C squared is 20 squared. We go ahead and simplify. 11 squared is 121 plus B squared equals 400. I'm going to go ahead and subtract 121 because I want to get that B squared by itself. Oh, looks like I put the orange instead of red. So this is going to be, this should be a 121. B squared is going to equal 279. You take the square root of both sides. And the square root of B squared is B. Square root of 279 is 16.7. All right, so the biggest thing is labeling and then setting up our Pythagorean theorem and solving for whatever missing variable. Go ahead and work on activity 7.8.1. Good luck.